Good day, everyone, and welcome to the Beers with Engineers podcast. You are at the place where we aim to provide a pint of fun and an occasional shot of geek. My name is Bert Ushold, and this is episode number 10. Yay, double digits! Today my guest is Charlie Sears, an engineer I have had the pleasure of working with for many years. First, a little bit about my company, Dexterity Engineering, where I provide medical device design and product design in general. I would love to help you get your product to the market. Plastic part design, DFM, tolerance analysis, whatever it takes. Please check out my website, dexterityeng.com, to learn about my background. With that taken care of, the title of this episode is Are Some Engineers Becoming a Commodity? That was something Charlie suggested, and we talked about it for a few minutes. We also talked about the Virgin Islands, ice rinks, and Scotch. There's a little bit for whatever interests you, so sit back, crack open a beer, or a Scotch if you want, and find out the rest of the story. Hello everyone! Today my guest is Charlie Sears, an engineer I have worked with for many years, but unfortunately not in many years. How are you doing today, Charlie?
I'm doing very well. Good to see you.
Good, yeah, likewise. It was a great pleasure to work with Charlie for 8 or 9 years. He's an excellent engineer. He was probably our most skilled pro engineer user back when that was a thing. In brainstorming sessions, you could always count on him to have many creative suggestions. He's just an all-around good engineer. That said, there is one little thing that I used to be a little envious of Charlie for, and I'm not sure I ever confessed it to him, so now here it is. It was his phone number, or specifically his extension at work, 1104. Why was I jealous, you might wonder? Because my birthday is November 4th, and I would have loved to have had my extension to be my birthday. C'est la vie. But I will add one more thing about that date, because that date is approximately each year when Charlie puts up his Christmas tree and starts listening to Christmas music. Much to my dismay, but Charlie is who he is, and I love him anyways. So, with that, our first question of the day. Well, I know the answer already, but so you are not drinking a beer, but if you were drinking a beer on this Friday afternoon, what would you want to be drinking?
You know, I've obviously as we get older, you know, our tastes change and things like that. So,
Sure.
I'm not so much of a beer drinker anymore, but if I do, you know, choose to have a beer, there's one called Kentucky Bourbon Ale.
Kentucky bourbon. I'm guessing there's
Yep.
a little bit of Kentucky bourbon in it.
So it's actually fermented in a Kentucky bourbon cask. So, you know,
Okay.
whenever you know a cask is used to make bourbon, they do not reuse the cask. So they have all these empty casks. What do they do with them? So they actually ferment beer in them, and the beer takes on a lot of the notes of a bourbon without
Okay.
the kick, right?
Well,
So
I apologize me for correcting you, but they do reuse them. Well,
do they? Okay,
yes and no. The bourbon distillers don't reuse them. The Scotch distillers reuse them.
got it.
So I
Okay,
believe you can go to distilleries and aging rooms or whatever in Scotland, and you'll see Jim Beam and Jack Daniels and all sorts of other things marked on the wood. That's my understanding. I think bourbon, by definition, has to be in a unused barrel, and I'm not sure if Scotch requires a used barrel, but they do have used barrels for Scotch.
got it. I should have clarified that the bourbon manufacturers do not
That,
reuse them.
that is correct. Bourbon manufacturers
Yes.
do not
Yep.
reuse them. All right, so there you go. We've got that out of the way. Question number 2. Do you have an engineering joke to share with us, Charlie?
I had to pull up Google. Right? I'm like, oh man, you know,
Really?
I really gotta, you know, I got to think about this. I was like, oh man, what am I going to find for a joke? But I do actually have one that I thought was pretty cute. And,
All right, good. Lay
you
it
know,
on me.
engineer walks into a bar and he runs right up to the bartender. He goes, quick, give me a beer or there's going to be trouble. And the bartender's like, oh my God, you know, geez, I don't want any trouble. You know, he goes, so he brings the guy a beer. The guy drinks it down. When he's done with the beer, he looks at the bartender and goes, quick, you better get me another beer. There's going to be trouble. And so the bartender's like, whoa, wow, okay, all right. So he gets him another beer and he gives it to him. And this goes on for another couple of beers. And the bartender's finally, you know, looking at him. He's like, you know, hey, buddy, when are you going to pay for these beers? And the engineer looks at him and goes, "Okay, here comes the trouble."
Keeps giving a beer until there's trouble. All right,
Yep.
awesome, awesome. All right,
Thought it was
very,
cute.
very good. All right, so we'll start with a little background on yourself. Why are you an engineer? A little background. Maybe when you're 12 years old, you've watched a Nova special on PBS or something. I don't know. What's your
So a
story?
long and winding road. It wasn't necessarily actually. I really thought I was going to be, a computer, in computer science, programming.
Okay.
Coming out of high school, so high school graduated '84 in high school,
Yep.
college '88, and
Same year as me.
back then, right? Computers were very, very rare and very expensive. Um, getting an Apple II, at school was life changing.
Right.
It was something that I just immediately gravitated towards, and was fairly successful at it. So, computers, networking, programming, and things like that, I thought was going to be my path forward. But the challenge, was essentially that, computer science and programming, was a career path forward, but the way you learned it and things like that weren't necessarily the way you learned other things. And through just pure hapstance, I ended up working at a company that was a manufacturer and had, plastics and injection molding and things like that. And I've always been, a person who likes to build. So, whether you were programming and using your hands or building, physical things, or, doing construction or something else like that, my mind again kind of gravitated towards the manufacture of things, the design and engineering of things. And back in the late 80s, CAD wasn't the thing. Drafting tables and drafting, was where my mind went towards. So I immediately switched and started down design engineering, and working at a company. I transitioned, worked at a company that manufactured, made, designed and engineered injection molds. So became very, very skilled at converting 2D drawings into 3D CAD, because the making a mold, learning how to manufacture a flat, parallel, square, working with graphite EDMs, and then candidly standing at a Bridgeport in a milling machine, counting rotations in order to measure out 1 inch 368 thou. The math, the science, the mechanics of it, all kind of resonated with me. And then, son of a gun, guess what happened with manufacturing? Computers came in.
So everything you're touching is turning into computers, Charlie.
Is coming back to computers. Yep. So all of a sudden, you have CNCs. So a lot of the machines that came up, were using G code, and the initial programs like Mastercam, came out. So basically call it, it was 3D, but it was all stick building, right? So it was all line, arc geometry projections, and things like that. So all of a sudden, networks, computers, programming, manufacturing, design, engineering led to a eureka moment with stereolithography. I'd read about it, I knew about it, through some design engineering courses. And
do you recall what year that was? About
89.
That early? Okay.
Yeah.
That's going way back. So you're.
Yeah. So funny story. Since this is Beers with Bert, and I will fill you in on this one. My wife actually found my next job position working at a company called Santon Engineering, which was up here on the North Shore in Beverly, Massachusetts.
Right.
I live on the North Shore. It was right down the street. And when I had learned about stereolithography, I thought there was no way I would ever be able to get involved with that, because the only people who could afford the $250,000 pieces of equipment, would be, the GEs, the IBMs, the Gillettes, the really big companies that would have infrastructure and teams, to support that type of activity. But Santon Engineering was a model shop. They, were big in pattern making and things like that. They had, castings. They were getting into injection molding, and, building injection molds and things like that, and rapid prototyping, 3D printing of parts for their casting operations and painting was a natural extension of what it is they wanted to do.
Sure.
But it was still very, very new. they were the first service bureau in New England, and they
And
hired me.
cool. That was when?
That was 90,
90. Okay.
1990. Yeah, 1990. 80, it was 80, late 89 or 90,
All right.
somewhere about there. And you needed the 3D CAD file, you needed an STL file in order to run the machine. And nobody had CAD. Nobody had those systems. I still remember the first computer that I had was a compact 38633 with, I think it might have been a Ytech Mathco processor with 16 megs of RAM
Right.
with like a $40,000 graphics card in it because it ran something called Ares Concept Modeler, which is an FEA package, and they were one of the few CAD systems out there that could output an STL file. So all of the modeling we did initially was with that package, which was, if anyone has done a lot of FEA, it's just very blocky. It's
Right.
If you have any type of organic shapes and things like that, it was not suited for that. And right about that time, parametric technology, was coming out with its Pro Engineer software, and I think I started in on Pro E at like release 5. If anybody goes way back, it was 5, 6, 7, 8, 9, all the way up to 19. Then it became 2000,
Yeah,
2009, 2009 squared, and
Yeah, I'm
kept changing.
I'm pretty sure that I first dabbled in it at 3. And
Sure.
then did very little, and then like a year later, the company upgraded to 5, and then I started getting a little more serious into it.
Yeah, there was a company called Rand Technologies that resold it in the area,
Okay.
and they came in and they were trying to sell us on it, and back then, what ran everything were Silicon Graphics boxes, the Unix boxes, and so you put a copy on our machine that was just an eval license,
Okay.
and it was fantastic, right? Relative to so Euclid, was another one we were trying to use. Alias was another one we were trying to use.
Remember Alias? Yep.
Right? Really swoopy surface. Oh God, C4 continuity, all that crap. And the Pro Engineer was just a much faster, much better tool for doing what we wanted to do.
Right.
And because of the pace at which you had to convert 2D drawings into 3D data files, you quickly became a little bit of a hack, right?
Mm-hmm.
You weren't designing something from a blank piece of paper. It was already designed. So, you had the ability to go directly to your final result as quickly as you could. And that taught you how to be fast, right?
Yeah,
And that taught you how, to, when you hit a roadblock, you were used to hitting roadblocks. You knew how to get around it. You know how to, fix the system.
Yeah. Yeah.
So,
So we
from
were,
there,
yeah. So we're the same age. I graduated high school '84, just like you did. And so we're kind of the first generation of engineers that have been using CAD since day one.
Yep.
Day one of our careers. I mean, I think I actually, as a co-op, our group got a CAD station to, I don't know, it was for using building stuff. It wasn't really for engineering work per se. And I dabbled with that, but still did some stuff on the board. And then, first year out of college, still doing stuff on the board, and then got a computer there. But then it was my second job. I was with Ethicon Endosurgery in Cincinnati, part of Johnson & Johnson. And at the same time, the less invasive laparoscopic surgery was taking off. And so Johnson & Johnson couldn't throw enough money at us. And, that was, I don't know, I think when I started, they already had the Pro Engineer, which they're kind of dabbling with. What they used much, much more, I mean, that was their primary design tool, or their primary design tool was CADS, computer vision. Computer vision, CADS was the software, computer vision was the company, I forget what it was.
CATIA, sure.
And then it was like around
Graphics.
Yeah. And then, Unix boxes, all that good stuff. But they also, it was about 92, somewhere around there, they purchased to have in-house an SLA machine. So they had a nice in-house machine shop. They had the SLA. They did the manufacturing there. So So yeah, it was a big company, not GE or Ford, but Johnson Johnson's not too far behind, and medical product development dollars are much easier to come by than automotive product development dollars.
Yeah. Yeah.
So, anyways,
Yeah. So it all led me to be, a design engineer. If we talk about what it was like, when we started, networking was, nobody had networks. You start, maybe if you had Lantastic, then Novell NetWare, came around, the Windows for Work groups, and there was so much infrastructure being rapidly developed that you ended up with just a lot of knowledge and experience on how these systems work. The fact that we had to work on a Unix box, understanding the internet, right? Understanding connectivity, all this stuff. Candidly, I think we were, right place, right time.
right.
You know,
Yep.
to do all this stuff. Injection molding now, design and engineering for injection molding, used to be the province of the United States. Used to laugh at the quality of the China molds,
Right.
pieces of junk that they manufactured, but
Yeah,
now
they're doing some pretty good stuff now.
yeah,
They're doing some pretty good
yeah.
stuff now.
So that's what kind of long-winded answer to why did you become an engineer? It's just because I really enjoy designing and making things, thinking about problems and problem solving. I view them as puzzles.
It's kind of like you were at work and saw, hey, that other guy, I want to do what he's doing. I don't want to do what I'm doing. That sounds pretty close. Yes, no?
Yeah,
Yeah.
yeah. Candidly, when we used to sit together, I was on the consumer products and you on the medical devices. I used to see all the medical device headaches that you would have, and I'd be like, oh, thank God I don't have any of that. Now my entire life is all about medical. But
Yeah, you made that jump. Well, that segues into one of my questions for you. So we both worked together at Radius. I left, and then you left a few years later, and you went to, it was what, Spine Frontier, the name of the company, and just
Yep.
cheating and looking at your LinkedIn, and I'm a little jealous of your title. I was jealous of your phone number. I'm jealous of the title, Innovation Manager.
Sure.
So what was that job like? So that took you away from Radius and into a 100% medical field.
Orthopedic spine devices.
Yep.
Yep. So when I entered the company, they were about 5 years, into development. So they were still kind of a startup company, and they were transitioning to, being profitable. And the business model was rapid development of spinal implants, spinal devices. So interbodies, cages, devices, rods, cervical, screws, plates, all this type of thing. It was an incredibly fast-paced environment. Like my first product, so Innovation Manager was, kind of a combination of, a product manager, engineering team lead, support service. You basically filled a lot of roles because
Sure.
they weren't a very big company, right? But the main function was principally as the mechanical engineer, lead engineer, product manager, working with supply chain and quality to commercialize your product. So my first product, was what's called an interspinal spacer. So people that have pinched nerves in their lower back,
Yep.
could use something like this. When I joined the company, we launched it 6 months later.
That's
We
pretty
received
quick.
regulatory clearance, and then we had our first case, I think about 2 months later. As part of that first surgery, 2 months later.
It's a little surprising to me that, especially at implantable, that the approval cycle be that quick.
Sure.
Is that?
So 510 submission, all right, so 90 days,
Yep.
equivalent to superior performance, it's pretty standard. And, there wasn't, the methodology behind the commercialization of a lot of those products was get yourself a predicate device, put it through
Right.
the test, get the test data, build your implant as quickly as you can, design and engineer it and build it as quickly as you can, test it, ensure that it's equivalent to superior, and then create the rest of the documentation for your 510. Right.
So for
So-
those, let me interrupt for 1 second. For those not as familiar with the medical device industry as Charlie and I, there's two ways to get your product approved for use. The first one which no one wants to do. I think it's a PMA, pre-market approval, and that's for something that's brand new, never been done before, and takes a long time. I won't try and quantify it, but longer than you want. And then the second option is what's called a 510K, where it's something there's something substantially equivalent to it already in the market, and you're just making an improvement in one shape or form. And so people bend over backwards, like you said, trying to find a predicate device so they can properly file for approval on a 510K instead of a PMA. So
Yeah.
just want to throw that in there. Sorry.
Yeah,
Continue,
no,
please.
and there's subtleties to those too, right? You
Yeah.
know, so de novo and things that don't require predicate submission, but still require notification to the FDA. So there's subtleties, but predominantly yes, right? You know, a lot of people are, go the 510K path because it's an accelerator,
Sure.
right? All you have to do is get equivalent to superior approval from the FDA.
Yep.
But yeah, so back then, there you were able to submit with statements like sterilization will be 10 to the minus 6. Steam sterilization, here's our parameters, 10 to the minus 6 sterility level, SAL.
Yep.
We didn't have to complete that, right? We didn't actually have to have the test data on file
Really?
prior to submission, right? All we had to do was tell them that this is what we were going to do, and they would write us back a very nice note that says, okay, you've claimed equivalent to superior. However, it is still on you to make sure that you complete all of your design controls. Okay. So, having the evidence that you did achieve your sterility ratio, right, at the temperatures and time and everything else like that you said you do, was necessary. So, but it allowed you to accelerate things, right? That 90-day submission, like once you submitted, we were off to the races. We were, finishing up the design and development and engineering of, instrumentation kits, doing the sterilization validations, and anything else like that.
It's just another path in the concurrent engineering. Well, I'm going to do concurrent engineering. I'm going to do concurrent FDA approval. Throw that in there as well.
Yes. Yeah. And I think a lot of people, candidly, they're very hesitant about that. They tend to be exceptionally conservative, in my mind, with regards to submitting to the FDA. It's like, well, if that's the way we see the world.
Conservative in what way?
So they're afraid of a request for additional information or FAI.
Okay.
Right. They're concerned about what a reject means from the FDA. Right. So if you submit and they come back and say no, you're denied. Right. So well, they're not going to deny you. They're just going to basically come back and say I need additional information or you need to do this or that. And so really all that does is they put you to a 45-day clock. Right. So if you're concerned about running that risk. Right. Well, in parallel, while they're reviewing it, do the work.
Yep.
If they come back and ask you for the work, then you can quickly come back and keep going.
Yep.
Slow gun, fast bullet, right? So if your level of success is once you submit, there are no requests for additional improvement. You just get your letter after 90 days. Then hold off. Make sure you have. Your T's double crossed, your I's double dotted, and submit.
Yep.
So
the paperwork of medical device development, so much fun.
Yeah.
So much fun.
Yeah. To your point about PMAs, right? I mean, that's just ridiculous.
All right. So let me take an opportunity to segue. So you didn't want to be medical. Now you are medical. Any piece of advice you might give to a younger engineer looking to get into medical device development or anything in the medical field?
Maybe not so much specific towards medical.
Sure.
I think the world is a little bit too simple for new engineers, meaning that they've grown up in a digital world. They've grown up with 3D CAD. You can buy a 3D printer off of Amazon for $1,500. I work with a number of people who have home 3D printers that are probably better than the machine I was using 30 years ago.
Yeah, I think it's a lot cheaper than $1,500. You can get them for like $150, I think.
Can you?
A couple $100, yeah. You're behind the times, Charlie. Get with it.
Crazy. But I think there's an over reliance and trust with regards to what they see on the machine, what they can print out, and the fact that they put it together.
Right.
So having some experience with manufacturing, or maybe even going to work for a manufacturer. So turning a handle, learning how to fixture something, learning how to make something, learning how something goes together. It teaches you where things can go wrong. Because I think people are just too optimistic. They just think things will work. Well, look at on the screen, and now I can animate it. I can just click on this and I can drag it. And look how cool all this stuff is. It all goes together. It all works.
Yep.
Yeah, well, maybe it works once. Can you design me something that works a million times?
Right. Yeah.
And then not just it works a million times, but I need to make a million.
Right.
So perhaps for the audience, right? Radius was affiliated with Nipro, and Nipro was a $1 billion worldwide custom injection molder.
Correct.
So they were used to working with, what were some of the Nokia projects?
Yeah.
I think you went to China and went to Brazil, right? I mean,
that's right. I did a lot of flying when I was working on that Nokia project. Yeah, I mean, Nipro, for the record, Nipro still exists. They were purchased by Jabil, I don't know, 5-6 years ago.
Yeah.
I had Ralph Thibodeau on one of the earlier episodes. I think you know Ralph, right?
Yeah, sure. Yeah.
Guy.
The you build the molds in China, 64 cavities, and you have to go qualify 64 cavities, and then you take the same part and you have to travel to Brazil, and you get another 30 up, mold that you have to build and qualify there. And the design and build of the molds are different, so therefore the tolerances associated with the part are different. And now you got to put them all together, and they all have to be interchangeable because your supply chain is using the same screen.
Yeah, right.
It's like nobody really considers that type of thing when they're going through their thought process on their design and engineering side, because all they're looking at is just something on a screen and then 3D printing. Yep. So I think getting a little bit more experience with actually making something, working on a machine versus just being 3D design and engineering and then printing, it would be helpful. Yeah. And I would also say learn how to create a drawing. A lot of people coming out of school, they slap a few views on and a couple of dimensions, and they think that's sufficient.
Right. It's funny. I'll circle back to the CAD a little bit, and so now, I get my SolidWorks solid model. I get the 3 views. I can slice anywhere I want, and I want hidden lines there, hidden lines removed, whatever I want. Back when we were using computer vision in CADs, it was just all wireframe. And so you could still make that view. And I remember this one particular example, I forget exactly what it was, but it was some part at an angle, and we were doing some weird view of it just so because you needed to see it to know what it was. And me and the designer working on it, we spent like 10, 15 minutes. What are the hidden lines? What aren't the hidden lines? The computer just didn't do it for you in a split second. But the other thing I want to mention, which I think you had, your training as an engineer, which is very advantageous. You started out in the machine shop, so you knew all that stuff, and I think it's very helpful, the practical end of it, especially when you're designing things. And I didn't have to that level. I didn't have that working with the machine shop. But one of my co-op terms, our department had a machine shop. We ran it for the company, and I think I used a few of the things just a little bit, but I was in there all the time talking to the guys and learning stuff, and it was a great introduction to machining, the importance of this, and the old the old joke, you gotta have the ID's got to be bigger than or smaller than the OD, and this is the old story of the young engineer giving the fabricator a tolerance where the tolerances on the ID kind of overlapped with the OD, and so he just gave him a handful of shavings. All right, here's your pipe. The OD is smaller than the ID. You see what happens when you do that.
Yeah, I'll be honest with you. One of my early projects in the orthopedic spine space, right? We were relying on the 3D CAD data. Our drawings were critical to function, and some overalls. And we sent them off to a machine shop. They gave us a very advantageous price and lead time to get these compressors made. Right. I got the thing back, and there was no bend, there was no radius on a portion of it, and I looked at it, and I'm like, this doesn't even look like the picture. How is it possible that you consider this to meet my print?
Right.
And I said, look, there's an arc here. And he said, there's no dimension. I said, because there's no dimension, that means you can just make it straight? And he said, well, there was no dimension. It's like,
all right. So I've always wondered if there were people like that.
yeah,
And, so A, you never go to that person again, I'm sure.
did not.
And, maybe legally they have some sort of standing, so, occasionally when, working on standard drawing notes, you want to have some sort of note just to make sure you don't run into some jerk that's going to do that to you. Because, like you said, if they do it to you, you're never working with them again, but you need that part that you expected him to build to look sort of like the picture in the drawing.
Yeah. I mean, if you get into an argument over, the design of your part, you've lost, right? You're going to have to get it remade. You're going to have to redo it. You're going to have to, you've lost time. You've lost money.
Right.
Even if they admit that they were wrong, like, well, you're going to have to pay me to fix it because you didn't have the dimension on there. It's like, oh, God damn it. Now there's more weeks. Now there's rework.
Yep.
And there's, that teaches you very quickly.
Yeah. School of hard knocks, as they call it.
Yeah. Yep.
So let me ask you this question. If my memory is correct, and thus far it seems to support it, my memory is you do not have a engineering degree. You might have an associate's degree. Is that correct?
Computer science, IT.
Computer science. So that's your degree is computer science. Okay.
Yeah. I ended up taking courses at UMass Lowell for plastics engineering.
Okay.
So anybody knows Driscoll. I did go over there for a little bit just because once I got into manufacturing, but then things went back to computers. So I was back in computers.
Yeah.
And
okay. So your degree's in computer science, and you're on-the-job training as an engineer.
Correct. All my work experience, is in manufacturing, design, and engineering, and now supply chain, quality.
Right. All right. So let me ask this question. So, part A, part B. When did you consider yourself to be an engineer instead of whatever else? And now that you're kind of in management,
about 10 years ago,
do you still consider yourself an engineer?
When did I consider myself to be an engineer? Probably it took, I would say, a long time, right? The whole design engineer versus mechanical engineer. I've always had the design engineer moniker.
Okay.
There are things if it ended up being more like a manufacturing engineer,
mm-hmm.
Once you really started to produce, once you really started to rely on your own judgment, your own decision making for what it should be and how it should be, materials, finish, creating the drawings and everything like that. Once you kind of transition to have that confidence, that experience, that knowledge, then I considered myself to be legitimate engineer, right? If you want to call it that. Not the piece of paper that says mechanical engineer, but
the piece of paper is easy to get, sort of. Well, it's interesting. You said you seem to distinguish between design engineer and mechanical engineer, and
mm-hmm.
One of my earlier guests, Nate Rollins, who you know well,
mm-hmm.
Had somewhat similar background where he started kind of hands-on and got his engineering degree nights, on the nights and weekends sort of thing.
Mm-hmm.
And he similarly said, I consider myself a design engineer, not a mechanical engineer. That's what he said. Mm-hmm. So how do you see the difference between those two?
If you asked me to calculate the power conversion on a motor to drive something over a particular distance, I could do it, but I'm gonna have to go to the books.
Sure.
Right. I wasn't trained in that type of activity. But if you told me to design, a fixture or an enclosure, for that particular, thing,
mm-hmm.
I could do that all day, every day, right? So, I think when it comes down to, what was an example that came up the other day? I think we were talking about Well, all right, let's just pick heat transfer, right? If you want to talk to me about heat transfer, I'll be like, not your guy.
Right, right.
Fluids and flow and dynamics and things like that. We actually did a number of projects at Radius, but we weren't doing any classical, type of analysis, free
Not
body
at the time.
diagram, type thing.
Right, right.
We physically tested it. We would design and engineer fixtures, and we would physically test flow and things like that.
Right.
So I would say any of those types of classical engineering tasks.
Yep.
You know.
So I guess, I mean, not that there's anything right or wrong. It's just that I would have considered design engineer as a subset of mechanical engineer, and it seems like
Sure. Yeah,
you,
I would agree with that.
okay.
Yeah.
I
I think there are probably some mechanical engineers who, couldn't design their way out of a box, right?
Yeah,
You know,
but then guys can analyze the snot out of something.
good,
And
sure, yeah. Back in the day, there are people who are very, very specific for FEA.
Sure.
ANSYS analysis, strength of materials, and things like that. Was a PhD level, type scenario.
Right. Right.
And now,
No,
you
no any schmuck can do it.
yeah,
some point.
yeah. I mean, always cautious, right?
Yeah.
I was like, oh, throw some FEA at it, throw some FEA at it. It's like, wow,
Garbage
why?
in, garbage out.
That's right. Let's make sure we're clear. Why we're spending the time and effort on these activities.
Yep.
But yeah, so I'm, so I consider myself to be a design engineer.
Mm-hmm.
For a long time, I also had my own shingle, that I hung out. So I worked nights and weekends.
Right.
For myself, working for another gentleman, and we did a lot of electrical enclosures and of the weird things you've ever designed in your life. One of them was a building on top of a roof that was to house an antenna array system. So was I speccing out the components? I was not. We had other people were doing that.
Yep.
Was I working with the team to place them in space and figure out where they would go and how they would go and what the serviceability was and how it could be packaged and moved upstairs because the doors are only so wide.
Mm-hmm.
Yeah.
All right. Very good. Very good. You wish you'd done something different in your career? It's like, I should have.
Software.
What's that?
Yeah, if you look at the industry right now, right, so
I'm sorry, I missed the answer. It was
stuck with software.
Stuck with software. Okay.
Stuck with programming, right?
Yeah.
If you when we started, right, CAD and design engineering and like that was all new, right? So there was a high demand, and if you could do it and do it well, you were successful. Gave rise to the product development firms.
Yep.
So I worked at Altitude, worked at Radius.
Yep.
What were some of the other? Worked with a number of design firms. Farm, Continuum.
Yep.
Oh God, I'm blanking on a lot of the names. But people who were skilled at CAD, skilled at design, skilled at engineering, gave rise to the product development firms. Now, I don't know. I think it's a commodity, right? I think being good at CAD, a little bit of a commodity. There's a lot of people coming out of school who.
Some of that. There's a big difference between knowing how to use CAD and knowing what to do with the CAD.
Sure.
If you give me a picture, a CAD operator gets a picture, create this. All right, I can create that, but they might not know what it's for, or especially if it's going to be a plastic part. With experience, that you can't do this because it's going to be an undercut when you try and make it, or the wall is going to be too thin for this side. There's a million different things you need to think about. I mean, there's a lot more than just operating the CAD.
Mm-hmm.
Why do you say that the PD world has been commoditized, Charlie?
So, looking back at our career, where we came from, the growth of computers, the growth of software, how expensive and prohibitive, there wasn't a lot of knowledge, 30 years ago in the industry. But by today's standards, computers are a fraction of the cost that they used to be. The software is a fraction of the cost that they used to be. You don't require expensive graphic cards, and the skill sets that we developed when we were younger are people are coming out of school now with them. They have training programs, they have internships, they have a number of things where their exposure to CAD development is common.
Right.
They know these environments. The things that they don't have, are clearly based around experience and knowledge, with regards to applying those skills to create something that works. They also tend to rely, I think, a little too much on 3D printing. So because they're so used to 3D files, they are able to create designs quickly. Then they can print them, and they think they're done. So I think a lot of those activities, those things that were fairly unique back when we started off in the industry, are much more common. You don't have to go very far to find a firm that has skilled CAD operators, 3D printing skills,
Yep.
design experience.
I guess I think it's hard to overstate the impact that 3D printing has had on product development.
Mm-hmm.
When I started 30-ish years ago, 35 years ago, they were just starting out. But, if you design something in CAD or even on paper, you want to make it, you had to machine it. Or, I think in some cases, the first time I saw a part was an injection molded part. So it was a sort of quickish turn aluminum tool. But, now I can see that part, I think of it today and go, I just get a quick idea what it looks like printed out, and tomorrow I'm looking at it. If you're going to invest several grand, at the time on a mold, you're going to make sure, you're going to spend a little more time making sure that it's right at the first time, or make sure it's right before you make that investment.
Sure. I'll never forget the day that Protolab.
Say again?
Protolabs.
Oh, Protolab, right.
Kind of came on the scene. So you could 3D print, you get very limited choice of materials, but all of a sudden, an organization that could take your CAD file, generate a quote, issue it back to you within a few hours, then you could order it with a credit card all online and have the part shipped to you within a few days.
Right.
Machined out of whatever material that you were looking for, and even back when they first started, some low volume injection molds was another accelerator. So your ability to the anxiety that you're speaking to, kind of the need to get it right the first time, because when you commit to, say, a hard tool or an injection mold, you wouldn't know whether or not your parts are going to work for weeks, if not months.
Yep. Yeah. So the whole CAD and 3D printing. I think back, maybe we talked about this earlier in our conversation, just the whole NASA and how the heck they put a rocket on the moon, put a man on the moon. And, I know I sometimes get a little bit lazy, I'm working CAD, instead of spending a few seconds doing some calculations, go, how do I center this, or how do I optimize this? I just trial and error. Well, how does an inch work? Nope. How does 0.9 inches work? How does 0.85 inches work? Until I get to something that works. And I don't know, sometimes I feel that's not the best way to do that, but I don't know.
Fail fast.
Little confession. Exactly.
Well, it is a different environment now. I will say that the most inconsequential detail that you will ever put into a product, into a design, into a part, has the unbelievable ability of causing you nothing but headaches.
Oh, right. Right.
I hate to say it, but I learn this lesson all the time. I get cute with my designs. I can do this because I can, and I think that little detail is inconsequential, but I'm kind of impressed with my skills.
Yep. Aren't I good? Look at me.
Then I get the part, and that stupid little detail has caught. It's like, why did I know better? I know not to be cute. I know not to, make something that is inconsequential important just because I over toleranced it, or I.
The other interesting thing is how quickly you can have in your hand something that looks like it's pretty close to done.
Mm-hmm.
You may have a 6-8 month product development cycle, and after a month, you're kind of there-ish. You've got your direction very well narrowed down. You 3D print a bunch of parts and you start showing around. Go, all right, you have releasing tools next month? No. This is just the first one. We got draft, just functionality. Does it work? Do the slides back and forth? Does it do what it's supposed to do? And I think even as a young engineer, just in my late 20s, I remember working with an insulin pump, not an insulin pump, but an insulin pen. And me and another engineer who was about my age said, "Yeah, we should be able to knock this out in a few months, right?" And all the other guys said, had worked on the last one, said, "No, it'll be a lot longer than that." But why? They couldn't really put a finger on why, but it just takes longer. And I look back at that and say, oh yeah, it looks like you can do it a lot quicker, but it just takes longer. Whether it's underestimating all the little things or high confidence in yourself, I'm not sure exactly what it is, but it definitely is. It's a truism. You can very quickly look like something that, oh yeah, we'll have that out to the market in 2 months.
I think underestimating and optimism are probably both sides of the same coin.
Yeah.
Oh, I can solve this.
Yep.
No problem. I can do that, half a day.
Yep.
But all the decisions and things that go into it. And by the way, just for the group, when Bert and I used to sit next to each other, I would swear that somebody asked me how long it would take to do something, and I would give them an answer. I would have to factor in at least a couple of pro engineer crashes, and then having to redo the work again the second time.
Well, I think as a co-op, some guys were talking about estimating things, and so I was like, all right, so you give your best estimate, and then multiply by pi because you're going to go around in circles once or twice.
I like that.
Yeah, but no, I do think I have improved on estimating how long something will take. And I do remember someone who worked with Paul Bertram, who and remember. I think he said something to the effect of, so if you're looking at your hours and budget and you feel like you got a lot of time left, you're probably going pretty good. If you feel like you're, running pretty good, you're probably over budget. And if you feel like you're behind, you're in big trouble. And that's, a different way of saying the same thing.
He's right. Yeah, by the time you recognize you're in trouble, you are so far down the road.
Right. Yeah, that, the inertia kills you in that point. All right, so let's go in a different direction.
Sure.
We've talked enough about boring work stuff. What do you do for fun, Charlie?
What do I do for fun?
What do you enjoy doing?
So we're traveling a little bit more.
Okay.
We're approaching 60. I realize people can't really tell that from the audio here, but all my kids are mid-20s, engaged, heading off to being married, and we're entering that phase where we're reestablishing ourselves and figuring out what we want to do and where we want to go, and what the next stage of life is going to mean for us. So my wife and I, we like to travel. So we put a lot of our time and effort into, they don't need to be big trips, just travel,
go
places.
So not big trip, you meaning not great distance or not long time or?
Either.
Okay.
Yeah. So had some customers down in Florida. Not that maybe Florida is a big trip, but we wouldn't think anything about jumping out there for 4 days, 3 nights.
Okay.
If she had to travel down there for a work event or something like that, I would join her. So
that works. That's fun.
Yeah.
So where do you like to go? Any one place in particular?
We're busy exploring the Caribbean.
Good.
A lot of the trips down to Florida with a customer spent quite a bit of time on JetBlue.
Okay.
And we accrued a number of points, and then we kind of discovered that a 2.5, 3 hour flight to Florida could easily be a 4 hour flight to pretty much any place in the Caribbean. And JetBlue right out of Boston travels direct to a lot of these places. So
that's handy.
it was kind of convenient.
Yep.
COVID hit, all of a sudden nobody was flying. So if you were cautious, and willing to get on a plane, the flights were very inexpensive, and you could travel.
That's
Continental
fun.
U.S. was
Do you have a favorite spot within the Caribbean, or just
St. John's.
St. John's?
Yeah.
That's nice.
So the U.S. Virgin Islands. So St. Thomas, St. John's. We haven't gone to St. Croix, but St. John's is basically a big national park for the majority of the island. So there's a lot of beaches and hiking trails and outdoorsy activity.
Yep.
If you like that type of thing, swimming, snorkeling. So
So you doing swimming, snorkeling, hiking, or you just on the beach getting tan?
yes, all the above.
Love it.
All
It's
the above.
vacation, Bert. That's what you do. Duh.
But there's a lot of great hiking,
Okay.
that people can go to, and we don't go in the high heat of summer, so we go in the off season. So when
Okay.
things are a little cooler, uh, in order to get out of the snowstorm we recently just had. But yeah, no, it's fun to get outside, get outdoors, meet other people, go to
So
different places.
my brain's just a little confused. You said Virgin Islands, St. John's, and I know my honeymoon we went to St. Thomas, and I think we did a day trip to St. John's.
hmm
If my memory's correct, kind of St. John's is less built up, but if you
Correct.
like the hiking and nature, that's the place to go. Is that my memory
Exactly
correct?
correct.
Okay.
All the cruise ships go into St. Thomas, so there's a lot of activity over there,
Yep.
and it's just a short boat ride to get over to St. John's.
No, I thought St. John's had a few cruises going there too as well. Or is that my memory
Not
wrong?
the cruise ships.
Not the cruise
They,
ships.
they don't have the harbor.
Not big enough. Okay. I guess
No,
I'm thinking of
don't
St.
even have an
John's.
airport.
Yeah. I know we also stuck over to the British Virgin Islands for a trip when we were down there.
Yep.
But so I think we established earlier we're pretty close in age, and you are an empty nester, and I have 3 boys in high school. So as I was thinking that, I was also recalling that my first child was born when we were working together, and I think you said something to the effect of, "Bert, what are you doing? Didn't you listen to everything we said?"
I think what I might have said was don't get them involved in hockey, and you didn't listen.
Oh, okay. I did not do that. I did not get them involved in hockey. We well, to the extent we actually did have a rink in our backyard for several years, and that was a lot of fun.
Yeah.
I grew up, never played on a team, but grew up in Buffalo, and there wasn't a pond, it was basically a glorified puddle.
hmm
But it's about a mile away, and I swear, 3-4 days a week, I was over there skating 2-3 hours till it got dark, and come home and do homework, go to school, lather, rinse, repeat, do it again the next day. That was just freaking awesome. I love
Yeah.
that.
Yeah.
And so to have the rink in the backyard, it started out very small, I think like 16 feet square. And then by the last year we had it, it was maybe like 20 by 32.
I was gonna say you have night lights and boards. And
Never got to never didn't get to boards other than just the 2x6 things there. I did try. It didn't work well, but it did actually painted a blue, not a blue line, a center line, and painted a big U for Ushold in the center of the rink, and that was fun.
so, being an engineer, I have to ask. So, what did you do for a Zamboni? Did you go on Amazon and buy one, or did you make one yourself?
Neither really. I just would shovel the ice and just flood it with another. I used to, I used to have a little Post-it note above my desk, which said roughly how many gallons or how many barrels it took me to give me a tenth of an inch of ice. And so, I would, especially when I was building up the rink, I would, I had a garbage can and fill it with water. I have a barrel filled with water, and I'd put that on the ice and fill it up again. And then I tend to wake up in the middle of the night. And so, 2, 3 in the morning, I'd wake up, go down, dump the water on the ice, dump the other water on the ice, go back to bed. Of course, put my nice cold feet up against my wife. She'd love that.
Yeah.
But
There's a lot of DIY or rink rake instructions you can
I've
find
seen
on
a few of
YouTube
those.
now.
Yeah, yeah.
So,
But the funny thing we did was, well, you learn how level it needs to be, and how when you look at something, oh yeah, that looks level. Oh no, it's not. No, it's not.
no.
And so actually, in the years while we were expanding the size, was fairly level, but not quite level enough. So if you come look at my yard, if you're a engineer who's done a plastic part development, there's what looks like an eject pad. So you've got the slight angle of the yard, and then there's like a little dugout in one section, and they'll add a material in the other section. So you get this flat spot, and then a little bit of hill. What the heck is that all about? So someday when we're selling that house, the real estate agent will have to explain what that is. That's the place for an ice rink.
Oh, that's a feature.
It's a feature, exactly. It's not a negative, it's a feature.
Yep.
So, all right. Well, I think we're getting close to wrapping this bad boy up. And we get to the grab bag question. And I'm just going to let the cat out of the bag. This is the second try of the second half of this interview. We had some audio problems. So Charlie may be thinking he's going to get to answer the same question again, but he is incorrect.
Yeah, I was going to pick a different number this time around. Maybe one if I got the same question, though. All right,
so just for fun,
7 then.
You're going with 7. All right. What is a favorite website that you use as part of your job? Maybe useful.
Got to be McMaster.
Yeah, I was about to say you can't say McMaster. What's the second one after McMaster?
Engineering Toolbox.
Yeah. Engineer's Toolbox? All right.
Yeah, they're a good one. But yeah, McMaster by far and away.
Yeah.
So I honestly think because back in the day we had to CAD everything. You wanted a screw, you couldn't get one off the web.
Yep.
You had to make the files. You had to make all the files.
Yep.
Make the configurations and everything else like that. I think having to do those activities, taught us how to make a screw, right?
Yep.
If you're talking about thread pitch, angle, grinding, and everything else like that, if you actually have to CAD something up like that you understand that even something as stupid simple as a dowel pin, they all have grades and tolerances associated with them.
Yep.
Now it's right out of the box. You can just get that right in SolidWorks. But I think I always found McMaster to be exceptionally useful in engineer's toolbox.
Yeah. Yeah. It was it my brother-in-law. He owns a company. They make pipe threading equipment, and somehow we're talking about it one day. He said he likes Grainger better. And I've gone to Grainger a handful of times, and I think their interface for searching is just a step or 2 or 3 below what McMaster is. They don't seem to have nearly the selection. Mm-hmm. I mean, McMaster's, this freaking get everything.
Yeah.
I've heard stories of people ordering things from McMaster that they didn't have, that they went and found and shipped to the person. And maybe that's what I do if you're a really good customer. But so. Just for the record, the question that was asked first time we tried this was if the sun made Charlie sneeze. And the sun does not make you sneeze, but it does make me sneeze. And I lost my notes here. It's called the photic sun reflex. And there's some theory that it may be caused because some visual nerves and nose nerves are getting too close to each other, and they're too close to each other, and signals are crossing and all that good stuff. All right, well, I think we're about done. Charlie, you get the last word. Any last thing you want to add, mention, say?
Yeah, we just, give some advice to, anybody who happens to listen to this. I think that, whenever I talk with people that I interview for, jobs, I always tell them that the individual who tends to be more successful than others, they share some attributes.
Yep.
The most common, for me, are they're motivated self-starters. So they basically come into a situation. They're new. So if you're the type of person who's looking for a 6-month learning curve, every time somebody asks something of you, like, well, I'm new, I don't really know what to do. That's understandable, but that's not necessarily in the consulting / contracting world that type of response, that type of attitude towards something that's new, something that's different, something you haven't seen before. You really have to be comfortable in that type of environment, and then go find the answer.
Right.
So that would be my recommendation to people who are kind of getting into this business.
Yeah.
If you can just be a motivated self-starter, you will be successful no matter where you go.
I was going to say be a go-getter. And excuse me, I'm just recalling that there's actually a book someone gave me years ago called, I think, The Go-Getter. and it's about this guy who does exactly that. The boss gives him a challenge, and as it turns out, it's sort of this made-up challenge, and he throws in some intentional roadblocks, and this guy just works through it. Mm-hmm. And I think if I had, I'm still in the last word for me, sorry, but if I was that guy and found out that all those hoops I did and worked through the weekend, yada, 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 was just a test, I think I might have been a little upset. Well, Charlie, this has been a great pleasure chatting with you. And,
you as well.
We do need to get to see each other face to face sometime, before my kids get into college.
Sounds good.
All right, take care, Charlie. Thanks.
All right. Bye. Thanks, Bert.
That wraps up today's episode, but I do want to add one thing. That book that I mentioned at the end, The Go-Getter, I just want to clarify the ending of it. Yes, it was a test that the boss had given to that man, but it was so that he could get a big promotion for a very important job. It was something that he just felt that he needed. And so the guy in the store was not upset like I suggested I was. He was proud that he passed the test and got himself a big promotion. So there you have it. Thank you for listening to the podcast, and you know the drill. Like, subscribe, tell your friends. If you want to be a guest, let me know. If you know someone that would be also want to be a guest, that's good too. We'll see you the next time. Thanks. Bye.